I have 2 times the cosine squared of x plus 3 sine x equals 0. Another equation I want to solve for x. This one, what I'm going to do is I see that I have cosines and sines both involved in the particular equation. So maybe there's a way that I can get them all in sines or cosines as my first major step. So what I'm going to do is, if I remember an identity for cosine squared of x. Well, cosine of x, if I remember, that was the same thing as 1 minus the sine squared of x. So I just used one of my substitutions that I've learned before. Let's go ahead and multiply that through. So I have 2 minus 2 sine squared of x plus 3 sine x equals 0. It looks like I'm building a quadratic. There's a quadratic kind of hidden there some a little bit. So let's put the highest term first. Minus 2 sine squared of x plus 3 sine of x plus 2 equals 0. I might be able to factor this, but I can factor it if it has a leading positive coefficient, or at least it's a lot easier. So let's multiply both sides by a -1. So then I have a 2 sine squared of x minus 3 sine of x minus 2 equals 0. So it looks like I can go ahead and start to begin factoring that. That's ugly. But if I kind of remember it as a 2 times a u squared minus 3u minus 2, I can factor that. So let's see if we can remember how to factor that. And then 2u, I need a +1 and a -2. So -2 here and a +1. Let's see, that gives me all my terms. 2u times a u is a 2u squared. My last term, +1 minus 2, gives me a -2. Middle term has to be a -3u, -4u plus a 1u. So that's how I can factor that one. If I can do that, I could do that because it's the same factoring. And I can even use that model right there if I want to kind of help me get a sense of what's happening, since u is just a sine in that particular case. So I have 2 sine plus 1 times sine minus 2 equals 0. Both sides make 0, so this is true when 2 sine plus 1 equals 0. Looks like that's the sine. Add the 1. A sine equals a -1/2. Just checking. Something just doesn't look right. Add the -1 to both sides. It gives me a -1. Divide both sides. I get a sine. Oh, there's an x. That's why I'm missing a long one. It was always the x that was there. So sine of x equals -1/2. And then on the other side, I have a sine of x equals a 2. So I know that my equation is solvable when one of these two equations are met, or both equations. Sine of x equals 2. I'm going to rule out any solutions right there to begin with, because I cannot have a sine value greater than 1 and it's telling me that it's a 2. So that's not going to produce any values over there. However, with this other one, sine of x equals -1/2. And I want to find out where all my values, where I have a -1/2 sine in this value, or in that range. And that's going to occur in the third and fourth quadrant. So to begin with, I'm going to try to find out what my acute angle is. And so the acute angle occurs in the first quadrant, where sine of x equals 1/2, and sine of x, so that's at the point where it's pi6. Pi6 equals x. So the sine of pi/2, or pi6, equals 1/2. That's in the first quadrant. I want to find out where do I have a negative sign at in those particular cases. So one way to get to the third quadrant is I add a pi to it. So pi plus this value, that's my third quadrant. 6/6, that equals a 7/6 pi. There's one value. To find the value in the fourth quadrant, if I remembered right, I took a 2 pi minus my acute angle. 2 pi, get common denominators. That becomes a 12 over 6 pi minus a pi over 6 equals 11 6 pi. And there's my other solution. So those are my two solutions that satisfy this equation within that particular range.